Hello and welcome to a new video on IGCSE Classified Paper 2 Physics. In this video, we shall be discussing sound waves. You will begin with the properties of sound waves, which row states two properties of sound waves. So you should know from the wave properties video that sound waves are longitudinal waves. But now we're also going to add a second classification, which is that sound waves are mechanical waves. So what are mechanical waves? Well, basically, you have two types of waves that you need to concern yourself with: mechanical waves and electromagnetic waves. So the idea is that electromagnetic waves can travel through vacuum. This is what sets them apart from mechanical waves. So what is a very typical example of an electromagnetic wave? Basically light. And if light were incapable of traveling through vacuum, then we would not get any sunlight. We would basically freeze to death and live in darkness. Well, we would freeze to death because of heat, but we would live in darkness because of the absence of light. And another type of electromagnetic wave is actually, speaking of heat, is actually infrared waves, which transfer heat from the sun to the earth. Now, these are waves that can travel through vacuum. However, all other waves cannot travel through vacuum. So basically, if you and your friend are up in space and you're trying to talk to each other, neither one of you would be able to hear the other. So sound waves, water waves, many other waves are mechanical waves which cannot travel through vacuum. And therefore, we pick, of course, sound waves cannot travel through vacuum, so we cross out A and B. So we're going to pick either C or D. And we said before that they are longitudinal waves, so we pick C as the correct answer here. Which row shows the natures of light waves, sound waves, and X-rays? So like we said, the only wave that is longitudinal in our curriculum is the sound wave. Therefore, of course, we automatically remove these two. These are out. And light waves and X-rays are both transverse because, like we said, only sound is longitudinal. So C would be the correct answer here. Candle flame is placed in front of a loudspeaker. The loudspeaker produces a sound wave that causes air particles to vibrate. The vibrating air particles make the candle flame vibrate in the same direction as the air particles. Which row shows the direction of vibration of the candle flame and the nature of sound waves? So like we said, sound waves are longitudinal, not transverse. So we can automatically cross out B and D. And one thing you should know about longitudinal waves is that the particles of the medium vibrate in the same direction of traveling of the wave. So if the wave is traveling to the right or horizontally in another sense, then the particles will vibrate horizontally as well. You can learn more about this in the wave properties video. So C here would be the correct answer. This would have been correct had it been a transverse wave, which does not apply to sound, of course. So anyway, C is the correct answer for this question. A sound wave travels through air as a series of compressions and rarefactions. So instead of crests and troughs, as we talked about with other waves, we have compressions and rarefactions that have to do with the idea of longitudinal waves, as shall follow right now. So we said that if the wave is traveling in this direction, the particles will vibrate in this direction. If it's a longitudinal wave, the particles will vibrate parallel to the direction of traveling of the wave. So in a sense, these two particles will vibrate far away from each other and then close to each other, and then far away from each other and then close to each other. And this creates what we call compressions and rarefactions. So looking at the question here, air pressure in a compression. Of course, in a compression, the particles are close together, so you have high air pressure. And in a rarefaction, the particles are far from each other, so you have lower air pressure. So therefore, we're going to go with choice B. Air pressure is higher in a compression and lower in a rarefaction. So this is the correct answer for this question. The diagram shows 4 sources of waves. Which source produces longitudinal waves? Of course, longitudinal means sound waves, pretty much. So we're going to go with choice C, the loudspeaker. Again, do not confuse radio waves and sound waves. So a radio transmitter creates radio waves. I know we like to associate radios with sound, but radio waves are something completely different. They're electromagnetic waves, whereas a loudspeaker produces sound waves. And the radio waves are transverse. Everything but the sound waves is a transverse wave. So the only wave that is not transverse is the sound wave. So C is the correct answer here. The diagram shows the air molecules in part of a sound wave at a particular moment in time. Which statement is not correct? So like we said, in sound waves, the way that the wave travels creates compressions and rarefactions, similar to this diagram here. So basically, this is what we call a compression. And this is an area of high pressure where the molecules or the particles of the air are close to each other. And this creates what we call a rarefaction, where the particles are relatively farther away from each other and we have low pressure. And since the wave is traveling and there is sort of a change with time, we can definitely assume that earlier in X, there was a compression because some of these particles will move to the right, some of these particles will move to the left maybe, and this will create a compression at X. Later, there will be a rarefaction, followed by another compression, followed by another rarefaction. So these statements are definitely both correct. This part of the wave is traveling horizontally. This is also correct. This part of the wave is traveling towards the top. This is definitely incorrect. And since we're looking for the incorrect statement, we're going to choose D as our choice. Which row states whether light waves and whether sound waves can travel in a vacuum? We mentioned this earlier in this video. We said that sound waves cannot, but light waves can travel. So the correct choice here is B. The sound waves cannot travel in vacuum, but light waves can. And the evidence for this is that we get our light from the sun, pretty much. So B would be the correct answer here. A box contains a list of 4 types of wave. How many waves are transverse? Like we said, only sound waves are longitudinal. So the others are all transverse waves. Of course, sound waves and ultrasound waves. So ultrasound waves are longitudinal, but ultraviolet waves are okay, they're transverse. So we count them among the transverse waves. So C here would be the correct answer. 3 of the 4 are transverse waves. A man is talking at the side of a house. He can be heard by a woman at the front of the house, even though she cannot see him. What is the explanation for this? Sound waves are longitudinal, light waves are transverse, sound waves are transverse, and light waves are longitudinal. Sound waves have a long wavelength, light waves have a short wavelength, or sound waves have a short wavelength and light waves have a long wavelength. So here is the thing. First of all, B is incorrect. Like it's conceptually incorrect because sound waves are not transverse, sound waves are longitudinal. A as a concept is correct, but it does not explain why the woman can hear the man. The only reason why the woman would be able to hear the man is that sound waves have a long wavelength, whereas light waves have a short wavelength. This is why a woman is able to hear a man even though she cannot see him. So you should know that basically light waves have a very high frequency and therefore a very short or a very low wavelength. Whereas sound waves have a long wavelength, but a very low, relatively low frequency. So C is the correct answer here. The diagram shows the Earth and its surroundings, through which labeled region can sound not be transmitted. We said that sound does not travel through vacuum, so therefore D would be the correct choice. However, it can travel through air, water, and solids. So D here is the correct choice. We now move on to two terms called loudness and pitch. You should know that loudness translates into amplitude, which we covered in wave properties, the previous video. And pitch translates into frequency. And this is the basis of all the questions that we shall answer next. So pitch is another term used to describe frequency only when we're talking about sound waves in particular. And loudness is a term that we use instead of amplitude when we're talking about sound waves as well. A quiet sound is produced by a loudspeaker. The loudness of the sound is increased. Which property of the sound wave is increased? So loudness, we said, corresponds to amplitude. So A is the correct answer. The frequency of a musical note is increased. A student hearing the sound detects an increase in which property? Like we said, frequency translates into pitch. So B would be the correct answer. A sound wave has certain amplitude and certain frequency. A second sound wave is quieter and lower in pitch. So quieter means that the loudness decreased, and the pitch means that the frequency decreased. So we want something with a smaller amplitude and a smaller frequency. And this, of course, makes sense. A singer sings two notes. The first note is louder and lower in pitch. So louder means that we have higher amplitude. Lower in pitch means we have less frequency. So we want larger amplitude and smaller frequency. So B would be the correct answer here. A fire alarm is not loud enough and the pitch is too low. An engineer adjusts the alarm so that it produces a louder note of a higher pitch. So both of them increased basically. So we're just going to go for larger and greater. So A here would be the correct answer. A siren is emitting a sound. As time passes, the sound becomes louder and higher pitched. So louder means the amplitude increases, higher pitched means the frequency increases as well. So D is the correct answer. I'm not taking my time with each question since you can see that the questions pretty much repeat themselves. So two sounds X and Y are produced by loudspeakers. The amplitude and frequency of each sound wave is given in the table. How does sound Y compare with sound X? So the amplitude for Y, you can, excuse me, let me redraw. So for Y, you can tell that the amplitude increased, but the frequency decreased. We're comparing to X. So I have a higher amplitude and a lower frequency. So higher amplitude means louder. Lower frequency means lower pitch. So we're going to go with B for this question. The diagrams represent the displacement in 4 different sound waves. All diagrams are drawn to the same scale. Which diagram represents the sound with the highest pitch? So the highest pitch means the highest frequency. So we're looking at the diagram that has the highest frequency, which is diagram D. Which property of a sound wave affects the loudness of a sound? We said that loudness translates to amplitude. Finally, we discuss audible frequencies. So frequencies that the human ear can hear. And you need to memorize that the human ear can hear between 20 hertz to 20,000 hertz. Or another way of writing it is 20 kilohertz. So from 20 to 20,000, you need to know both these numbers. Why can ultrasound not be heard by humans? Remember that we're talking about audible frequencies. So ultrasound has a frequency that is greater than 20,000 hertz. And therefore, since the frequency is too great, we cannot hear ultrasound, unlike bats, which can actually hear and communicate through ultrasound. So B would be the correct answer. What is the approximate range of hearing for a healthy human ear? That's 20 to 20,000. So not 2 to 2,000, not 2 to 20,000, not 20 to 2,000, but 20 to 20,000. And you need to memorize these two numbers. So D is the correct answer here. Which range of wave frequencies includes only sounds that can be heard by a human with normal hearing? So we're looking at something between 20 and 20,000. So 3, this is less than 20, so incorrect. 30 to 3,000, these are all within my range. 300 to 30,000, so 30,000 is more than 20,000, so this is incorrect. And again here we have 300,000, which is more than 20,000, so this is incorrect as well. So B is the correct answer. A dolphin has a range of audible frequencies of 150 to 150,000. Which range of frequencies can be heard by both humans and dolphins? So for humans, we have from 20 to 20,000. For dolphins, I mean, we have from 150 to 150,000. So for a sound to be heard by both humans and dolphins, it has to be the area in between. So basically, this area here. So from 150 to 20,000. So we're looking for something that is between 150 and 20,000 so that it can be heard by both humans and dolphins. So D would be the correct choice in this question. So the diagram shows the ranges of human hearing and of ultrasound waves. To which characteristic of sound waves do the numbers refer? Of course, like we said, from 20 to 20,000 hertz, right? So this is the range of frequency that can be detected by the human ear. And as you can see, for ultrasound, the frequency is higher than 20,000 hertz. So anyway, B is the correct choice here. Sounds are produced by vibrating objects. A certain object vibrates, but the person nearby cannot hear any sound. Which statement could explain why nothing is heard? Obviously, the frequency of vibration is too high, because if the loudness is too high, we're going to hear it, but our ears would hurt us, right? So the only case where we cannot hear something is if the frequency is too high. So B is the correct answer here. What is ultrasound? Sound waves that are so loud that they damage human hearing. This is incorrect, because ultrasound does not damage human hearing or anything, because we actually use ultrasound in medicine. So if it had damaging effects on our hearing, we would not use it on a daily basis in hospitals and so on. So sound waves that are too high pitched, yes, High-pitched means high frequency, and we just said that ultrasound has a greater frequency than 20,000 hertz, which is why we cannot hear it, but bats can. And low-pitched would be wrong, too quiet would be wrong. So B here is the correct answer. And this brings us to the end of our video. Thank you for watching. I hope this was useful.